Welcome, dear friends, to the Bedtime Lab, where the gentle embrace of sleep and the enchanting wonders of the universe come together. Here in our cozy corner, we delve into the mesmerizing world of science, guiding you towards restful slumber with stories that spark curiosity and soothe the mind. Tonight we have a truly fascinating journey ahead as we explore the mysterious phenomena known as gamma-ray bursts. Before we begin, I'd love to know where you're joining us from. Please feel free to share your part of the world in the comments below. It's always a delight to gather together with friends from all over the globe. Now, let's embark on our exploration. Did you know that gamma-ray bursts are the most energetic events in the universe since the Big Bang? Imagine a single burst releasing more energy in a few seconds than the Sun will in its entire 10 billion year lifetime. It's almost unimaginable, isn't it, that such power could exist beyond our everyday experience? Here's something intriguing. Gamma-ray bursts were first discovered by accident in the late 1960s. During the Cold War, the United States launched satellites designed to monitor for nuclear explosions. Instead of finding what they expected, they stumbled upon these mysterious cosmic explosions. Can you imagine the surprise of scientists when instead of earthly threats, they found evidence of these distant cataclysms? Speaking of surprises, gamma-ray bursts can release as much energy in a matter of seconds as our entire galaxy emits in a year. Isn't it astonishing to think that in the blink of an eye, an event so far away can outshine an entire collection of hundreds of billions of stars? And here's something fascinating. There are two main types of gamma-ray bursts, short and long, each with its own mysterious origin. Short bursts, less than 2 seconds long, are believed to occur when two neutron stars collide, while long bursts, lasting from 2 seconds to several minutes, are thought to be the result of massive stars collapsing into black holes. Imagine the cosmic fireworks playing out light years away as these colossal events unfold. Speaking of cosmic distances, did you know that gamma-ray bursts can be detected from billions of light years away? These events are so bright that they can be seen across the universe, allowing astronomers to peer back in time and observe galaxies as they were billions of years ago. It's like looking into a time machine, granting us glimpses into the ancient history of the cosmos. And here's another fascinating insight. The first optical afterglow of a gamma-ray burst was detected in 1997, over 30 years after the bursts were first discovered. This afterglow, seen in longer wavelengths like X-rays and visible light, provides crucial information about the burst's environment and helps scientists understand these enigmatic events better. Can you imagine a gamma-ray burst? Thankfully, it's incredibly rare, but if it were to happen too close to Earth, the consequences could be dire. The high-energy radiation could strip away the ozone layer, leading to mass extinction events. However, rest assured, there are no known threats in our cosmic neighborhood for the foreseeable future. And did you know that gamma-ray bursts might have played a role in the early evolution of life on Earth? Some scientists speculate that one of these bursts, far away and long ago, could have influenced the conditions necessary for life to flourish by altering climate patterns or even triggering genetic mutations. It's a humbling thought that such distant events could have shaped our very existence. Speaking of shaping existence, there's a fascinating theory that gamma-ray bursts could be used as navigational beacons for interstellar travel. Because they are so bright and visible across vast distances, future space travelers might one day use them as reference points, much like ancient mariners used the stars to guide their journeys across the seas. And here's a thought-provoking fact. Gamma-ray bursts can help us understand the mysterious dark energy that makes up most of the universe. By studying the light from these bursts as it travels through space, scientists can learn about the expansion rate of the universe and delve deeper into the enigmatic nature of dark energy. Imagine, if you will, that the light from a gamma-ray burst is like a cosmic message in a bottle, traversing the universe to reach us. Each burst carries with it secrets from distant corners of the cosmos, stories of creation and destruction on a grand scale. As we unravel these mysteries, we not only learn about the universe, but also gain insight into our place within it. Lastly, here's a gentle reminder that despite their immense power, gamma-ray bursts are fleeting events. They remind us of the transient nature of the universe, where even the most powerful phenomena come and go, leaving behind only whispers of their existence. In this vast cosmos, we are all part of a grand story, each moment precious and fleeting. I hope these tales of gamma-ray bursts have sparked a sense of wonder and curiosity within you. As you drift towards sleep, let your dreams take you on a journey across the stars, where the mysteries of the universe await. Rest well, dear friend, and may the tranquility of the night envelop you in its gentle embrace. Thank you for joining me here at the Bedtime Lab, where together we explore the wonders of the universe before welcoming the peaceful embrace of sleep. Let's continue this soothing journey through the cosmos with more intriguing revelations about gamma-ray bursts. These extraordinary events offer us endless mysteries to ponder. Have you ever wondered how scientists can detect something so fleeting and distant? Well, the secret lies in space-borne observatories that keep a vigilant watch over the skies. Instruments like the Swift satellite are designed to detect the high-energy gamma rays in real time, allowing astronomers to swiftly track down their origins. Isn't it remarkable to think of these technological eyes scanning the universe, capturing fleeting starlight from billions of years ago? Speaking of capturing light, did you know that the afterglows of gamma-ray bursts can last for weeks or even months? These afterglows provide a wealth of information as they gradually shift from gamma rays to X-rays and then to visible light. It's as if the universe is slowly revealing its secrets, layer by layer, through these cosmic remnants. Imagine the dedication of scientists as they gather every piece of this celestial puzzle, waiting patiently for the universe to whisper its ancient stories. Here's something to ponder. Gamma-ray bursts are not just solitary explosions. Sometimes they are accompanied by supernovae, a spectacular finale to a massive star's life. These supernovae can enrich the surrounding space with heavy elements, essential for forming new stars and planets. It's a breathtaking cycle of destruction and creation, where the end of one star's journey becomes the birthplace of countless new ones. Can you imagine this cosmic dance, where life and death intertwine on such a grand scale? Moreover, gamma-ray bursts are so powerful that they can temporarily outshine their entire host galaxies. Just picture this, a single burst, brighter than billions of stars combined, lighting up the universe. It's a humbling reminder of the vast energies at play in the cosmos, making even the mightiest of our technological achievements seem modest by comparison. Here's a curious thought. The study of gamma-ray bursts has helped scientists understand more about the structure of our universe. By observing how these bursts are distributed across the sky, researchers can map out the distribution of matter, offering clues about the underlying framework of the cosmos. It's like piecing together a cosmic jigsaw puzzle, where each burst adds a new piece to the ever-expanding picture. Did you know that the energy from a gamma-ray burst can be so intense that it warps the space-time around it. Just like a stone thrown into a pond creates ripples, these bursts send out gravitational waves, disturbances that travel through the fabric of space-time itself. Imagine the universe as a vast cosmic ocean, with waves carrying tales of distant cataclysms across the void. Speaking of cosmic tales, gamma-ray bursts have inspired many myths and legends throughout history. Ancient cultures, watching the night sky, might have seen these bright flashes and woven them into stories of gods and heroes, interpreting them as messages from the divine. It's fascinating to think that even before we understood their true nature, these celestial events have stirred the human imagination. And here's a delightful fact. Some gamma-ray bursts are believed to be associated with the births of magnetars, a type of neutron star with incredibly powerful magnetic fields. These magnetic fields are so intense that they can distort atoms, stretching them into elongated shapes. Imagine a world where the very fabric of matter is pulled and twisted by unseen forces, a realm where the rules of physics as we know them are bent to their limits. On the topic of limits, it's intriguing to consider how gamma-ray bursts challenge our understanding of physics. The conditions within these bursts are so extreme that they push the boundaries of our theories, providing a natural laboratory for testing the laws that govern the universe. Scientists use these bursts to explore fundamental questions about the nature of matter and energy, seeking answers that could unlock the deepest mysteries of the cosmos. Add to this the fact that gamma-ray bursts are some of the oldest phenomena we can observe. The light from these bursts travels across vast distances, taking billions of years to reach us. When we detect a gamma-ray burst, we are witnessing an event from the distant past, a relic from a time when the universe was young. It's as if we are looking back in time, glimpsing the early chapters of the cosmic story. Did you know that the study of gamma-ray bursts has advanced our understanding of the early universe? By observing how these bursts change as they travel through space, scientists can learn about the conditions of the universe in its infancy. It's a bit like being a cosmic archaeologist, uncovering the layers of history etched into the starlight. And while we marvel at these distant explosions, it's worth remembering how they connect us to the broader tapestry of the universe. Each burst serves as a reminder of our place in the cosmos, a fleeting moment of brilliance that echoes through the vastness of space. As we unravel the secrets of gamma-ray bursts, we gain a deeper appreciation for the universe's grandeur and complexity. So, as you let this knowledge wash over you, imagine yourself drifting among the stars, where each gamma-ray burst lights the way, guiding you through the mysteries of the night. Let the serenity of the cosmos cradle you, bringing peace and wonder to your dreams. As you continue to drift through this cosmic journey, let me share another intriguing thought with you. Did you know that gamma-ray bursts can actually help us understand the rate of star formation in distant galaxies? These bursts act as cosmic lighthouses, illuminating the regions where new stars are born. By studying them, scientists can glean insights into the life cycles of galaxies, much like a botanist observing the seasonal bloom of flowers in a distant meadow. This connection between gamma-ray bursts and star formation is a testament to the intertwined nature of celestial processes. Speaking of connections, here's another captivating fact. Some gamma-ray bursts might be linked to the mysterious phenomenon of fast radio bursts. These are extremely bright radio pulses that last only a few milliseconds. Although their origins remain largely unknown, some scientists speculate that the same cataclysmic events responsible for gamma-ray bursts could also generate these fleeting radio signals. Imagine the excitement of uncovering such a link, potentially unifying two of the universe's most enigmatic phenomena. It's also fascinating to consider the role that gamma-ray bursts play in the synthesis of heavy elements. When these bursts occur, they release massive amounts of energy, which can lead to the creation of elements like gold and platinum. So, the next time you admire a piece of jewelry, you might ponder the cosmic origins of its precious metals forged in the heart of a distant gamma-ray burst. Isn't it incredible how the vastness of space can be so intimately connected to the things we treasure here on Earth? And here's an astonishing thought. Gamma-ray bursts have been detected in distant galaxies billions of light-years away, yet they are powerful enough to be observed on Earth. This ability to traverse such vast distances speaks to their immense energy. It's as if these bursts are cosmic messages sent from the far reaches of the universe, offering us glimpses into events that occurred long before our planet even existed. Can you imagine receiving such a message, older than time as we understand it? On the topic of time, consider this. Gamma-ray bursts occur with no warning and are over in a matter of seconds to minutes, yet their after effects can linger for weeks or even months. This fleeting nature makes them both elusive and captivating to study. Scientists must remain ever vigilant, ready to capture these transient events before they vanish into the cosmic tapestry. It's a delicate dance of observation and timing, reminding us of the ephemeral beauty found in the universe. Let's delve into another curious aspect. Some gamma-ray bursts are thought to result from the collision of neutron stars. These incredibly dense stars spiral closer and closer together, eventually merging in a dramatic explosion that releases a burst of gamma rays. This cosmic collision is a powerful reminder of the dynamic and ever-changing nature of the universe. Who could have imagined that the dance of two distant stars could end in such a spectacular display? As we explore these cosmic wonders, it's important to reflect on the potential impact of gamma-ray bursts on our own planet. While the likelihood of a burst occurring near Earth is extremely low, it's fascinating to consider how such an event could affect life. The intense radiation from a nearby gamma-ray burst could strip away a planet's atmosphere, potentially leading to mass extinctions. It's a sobering reminder of the delicate balance that sustains life on our fragile world. Yet, in the vast expanse of space, these bursts also offer a sense of awe and wonder. Their sheer power and unpredictability inspire scientists to push the boundaries of knowledge, seeking to understand the forces that shape our universe. And here's another delightful thought. The study of gamma-ray bursts has driven technological advancements in telescopes and detectors, improving our ability to observe other cosmic phenomena. These advancements represent the human spirit of exploration, fueled by a desire to uncover the mysteries of the cosmos. On the lighter side of discovery, did you know that gamma-ray bursts have been humorously referred to as the fireworks of the universe? This nickname captures the sense of spectacle and surprise these bursts bring, lighting up the cosmic stage with their brilliant displays. It's a playful reminder of the joy and wonder that scientific exploration can bring, encouraging us to look up at the night sky with renewed curiosity. As we continue our serene journey through the stars, consider this. Each gamma-ray burst is a unique event, shaped by the specific conditions and processes that led to its creation. This individuality means that every burst tells its own story, a distinct chapter in the grand narrative of the universe. By piecing together these stories, scientists hope to uncover the deeper truths that govern the cosmos, much like a storyteller weaving a tapestry from countless threads. Did you know that gamma-ray bursts are not just random occurrences? In fact, they are more likely to be found in certain types of galaxies, particularly those that are rich in star formation. It's as if these galaxies are cosmic nurseries, bustling with the activity of birthing and dying stars, and in such environments, the conditions are ripe for the dramatic events that lead to gamma-ray bursts. Speaking of dramatic, some of these bursts are so powerful that they can briefly outshine the entire galaxy in which they reside. Imagine a single event so luminous that it eclipses all the billions of stars around it, leaving an imprint on the universe that echoes across time and space. Here's something intriguing. The energy released by a single gamma-ray burst can be comparable to the amount of energy our Sun will emit over its entire 10 billion-year lifetime. This staggering comparison helps put into perspective the truly immense power contained within these celestial phenomena, and while the bursts themselves may last only moments, the afterglow they leave behind can persist for much longer, providing scientists with valuable information about the surrounding environment and the nature of the explosion itself. It's like following a trail of breadcrumbs back to the scene of a cosmic mystery, each clue offering new insights into the powerful forces at play. Have you ever wondered how these gamma-ray bursts are detected? Given their unpredictable nature, scientists rely on a network of satellites and ground-based telescopes to catch them in the act. These observatories are constantly scanning the skies, like watchful guardians ready to alert researchers the moment a burst is spotted. This global effort highlights the collaborative spirit of the scientific community, united in the quest to unravel the secrets of the universe. It's a testament to human ingenuity and perseverance, as scientists work together across continents and disciplines to piece together the puzzle of gamma-ray bursts. Speaking of piecing together puzzles, one fascinating aspect of gamma-ray bursts is how they can be used to probe the early universe. Because light takes time to travel, when we observe a gamma-ray burst from a distant galaxy, we are actually looking back in time, sometimes billions of years into the past. This makes gamma-ray bursts invaluable tools for studying the conditions of the early universe, offering a glimpse into a time when galaxies were forming and evolving. It's like having a time machine, allowing us to explore epochs long before our solar system came into existence. And here's a captivating thought. Gamma-ray bursts might also help us understand the mysterious force known as dark energy. By observing the effects of these bursts on the expansion of the universe, scientists hope to gain insights into this elusive phenomenon that is believed to be driving the accelerated expansion of the cosmos. Dark energy remains one of the greatest mysteries in physics, and gamma-ray bursts could hold some of the keys to unlocking its secrets. It's a tantalizing prospect, inviting us to delve deeper into the unknown and challenge our understanding of the universe. Now, let me tell you about something truly extraordinary. Some gamma-ray bursts have been found to exhibit a peculiar pattern known as an ultra-long duration. These bursts can last for several hours, far exceeding the typical lifespan of seconds to minutes. The cause of this extended activity is not fully understood, but it suggests a more complex underlying mechanism. Perhaps it involves a massive star that is slowly being consumed by a black hole, or a series of explosive events triggered by a star with an unusually large hydrogen envelope. These ultra-long bursts add another layer of mystery to an already enigmatic phenomenon, inviting further exploration and study. Did you know that gamma-ray bursts can also play a role in advancing our understanding of fundamental physics? By analyzing the light from these bursts, scientists can test theories about the fabric of space and time, such as the potential effects of quantum gravity. This branch of physics seeks to reconcile the principles of quantum mechanics with those of general relativity, two foundational theories that describe the universe on vastly different scales. Gamma-ray bursts offer a natural laboratory for testing these ideas, providing a bridge between the very large and the very small, and helping to further our understanding of the universe's most basic building blocks. Let's also consider the potential impact of gamma-ray bursts on the habitability of planets. While a burst occurring in our cosmic neighborhood is unlikely, the implications are profound. A nearby burst could strip away a planet's ozone layer, exposing life to harmful radiation and potentially leading to a mass extinction event. This serves as a reminder of the delicate conditions required to sustain life and the myriad factors that can influence planetary environments. Yet, it also spurs us to appreciate the resilience of life and the tenacity of ecosystems that have weathered countless cosmic challenges throughout Earth's history. Here's another interesting tidbit. Gamma-ray bursts can help us chart the distribution of matter in the universe. When a burst occurs, the light travels through vast swathes of intergalactic space, encountering clouds of gas and dust. By studying how this light is absorbed and scattered, scientists can map the distribution of these cosmic structures, offering insights into the large-scale architecture of the universe. It's a bit like using a flashlight to illuminate the contours of an unfamiliar landscape, revealing hidden features and deepening our understanding of the cosmic web that binds galaxies together. Finally, consider this poetic notion. Gamma-ray bursts are fleeting yet transformative, much like a sudden storm that sweeps across a tranquil sea. In their brief existence, they shed light on the darkest corners of the universe, uncovering its secrets and inspiring awe in those who observe them. As we continue to explore these remarkable phenomena, we are reminded of the infinite wonders that await us in the cosmos, beckoning us to venture ever deeper into the night sky, where the story of creation is still being written. Let's delve deeper into the captivating world of gamma-ray bursts. Imagine for a moment that these cosmic fireworks are not just solitary events, but sometimes occur in pairs. Indeed, some bursts are followed closely by a second, softer burst known as a precursor. This intriguing phenomenon suggests a complex sequence of events, hinting at interactions between the collapsing core of a star and its surrounding material. It's as if the universe is sending out a prelude before the main performance. Now, here's an astonishing thought. Gamma-ray bursts are considered to be among the brightest and most energetic events in the universe. In an instant, they can release more energy than the sun will emit over its entire 10 billion-year lifetime. Can you wrap your mind around the sheer power contained in these bursts? It's a staggering reminder of the scale and intensity of cosmic processes, dwarfing even the most extreme forces we encounter on Earth. Speaking of incredible energy, did you know that gamma-ray bursts can create afterglows in different wavelengths of light? As the initial burst fades, it continues to emit light in the X-ray, ultraviolet, visible, and even radio spectrums. This afterglow can last from days to weeks, providing a wealth of information to scientists eager to unravel the mysteries of the initial explosion. It's like a lingering echo, reverberating through the cosmos and offering clues to its origin. Here's something particularly fascinating. The study of gamma-ray bursts has helped refine our understanding of distances across the universe. By examining how the light from these bursts shifts due to the expansion of the universe, scientists can measure vast cosmic distances, a method that contributes to our comprehension of the universe's structure and growth. This technique adds another layer to the cosmic map, guiding our exploration of the stars. You might be intrigued to learn about the role of gamma ray bursts in the study of the cosmic microwave background radiation. This ancient light, a relic from the Big Bang, fills the universe. By observing gamma ray bursts that pass through this background, scientists can gain insights into the conditions of the early universe, enhancing our understanding of its evolution and the forces at play during those formative moments. Let me share an intriguing fact about the origins of gamma ray bursts. While many come from distant galaxies, a subset originates much closer to home, within the Milky Way. These are known as soft gamma repeaters and are typically linked to magnetars, which are neutron stars with extraordinarily strong magnetic fields. These local bursts reveal the dynamic and sometimes violent nature of objects within our own galaxy. Considering the vast distances involved, it's remarkable that gamma ray bursts can sometimes be observed with the naked eye. In 2008, a burst known as GRB 080303 was so bright that it was briefly visible without telescopic aid. It was an extraordinary event, reminding us that the universe occasionally offers a fleeting glimpse of its wonders to anyone willing to look up at the right moment. This brings us to another captivating aspect. Gamma ray bursts are often associated with supernovae, the explosive deaths of massive stars. When a star goes supernova, it can trigger a gamma ray burst, providing a dramatic finale to its life cycle. This connection not only enriches our understanding of stellar evolution, but also highlights the interconnected nature of cosmic events. And here's a curious notion. Some gamma ray bursts are believed to result from the merger of two neutron stars or a neutron star and a black hole. These cataclysmic collisions release gravitational waves, ripples in the fabric of space-time. By detecting both the gamma rays and gravitational waves from such events, scientists can gain a more complete picture of these violent and transformative cosmic dances. Perhaps you'll find it interesting that gamma ray bursts serve as cosmic beacons, helping astronomers identify new galaxies. When a burst is detected, it often leads to the discovery of a previously unseen galaxy, as bursts typically occur in regions of star formation. This makes gamma ray bursts invaluable tools for mapping the universe and understanding where and how galaxies form. Another intriguing fact is the variability in the duration of gamma ray bursts. While some last mere milliseconds, others can stretch over several minutes. This variability hints at the different processes and environments that can give rise to these bursts, further emphasizing the diversity and complexity of cosmic phenomena. Did you know that the study of gamma ray bursts has influenced the design of satellites and telescopes? Instruments must be highly sensitive and capable of rapid response to capture these fleeting events. This technological advancement benefits not only the study of gamma ray bursts, but also enhances our overall observational capabilities across a wide range of astronomical phenomena. Reflecting on gamma ray bursts, you might wonder about their role in the broader cosmic narrative. As we probe these mysterious and powerful events, we are not only unlocking secrets about the bursts themselves, but also gaining insights into the life and death of the most massive stars, the formation of black holes, and the evolution of the universe itself. Each burst acts as a storyteller, weaving together threads of cosmic history that stretch across time and space. Finally, contemplate this beautiful thought. Gamma ray bursts, in their brief yet brilliant existence, serve as a reminder of the transient nature of all things in the universe. Like cosmic fireworks, they illuminate the sky, captivating our imagination and beckoning us to explore the mysteries that lie beyond the stars. As we continue to study these enigmatic phenomena, we are reminded of the boundless curiosity that drives us to seek answers, to understand our place in the cosmos, and to marvel at the wonders of the universe that continue to unfold before us. Have you ever considered how gamma-ray bursts might affect life on Earth? While it's unlikely, a sufficiently close gamma-ray burst could have significant impacts on our planet's biosphere. The intense radiation from such an event could deplete the ozone layer, increasing harmful ultraviolet radiation reaching the surface. It's a humbling reminder of our vulnerability within the vast cosmos. Speaking of cosmic interactions, did you know that gamma-ray bursts are used to probe the interstellar medium? As the gamma rays travel through space, they can interact with dust and gas, revealing information about the composition and density of the material they encounter. This process gives astronomers valuable insights into the conditions and structures of distant cosmic environments. Let me share something intriguing about the energy of gamma-ray bursts. In just a few seconds, a gamma-ray burst can release as much energy as the Sun will emit over its entire 10 billion-year lifetime. This staggering amount of energy highlights the power of these cosmic events and underscores why they are one of the most energetic phenomena known to science. Have you ever wondered how gamma-ray bursts are detected in real time? To catch these fleeting bursts, a network of satellites equipped with gamma-ray detectors constantly scans the sky. Once a burst is detected, these satellites immediately alert ground-based observatories, allowing them to quickly point their instruments at the burst location. This rapid coordination ensures that scientists gather as much information as possible about these transient events. Here's a fascinating tidbit. Gamma-ray bursts can be used to test the fundamental laws of physics. For example, by analyzing the polarization of light from a gamma-ray burst, scientists can test theories about the nature of light and the structure of space-time. These observations provide a unique laboratory for examining the principles that govern our universe. You might find it curious to learn that gamma-ray bursts can occur in clusters. Sometimes, bursts appear in quick succession, which scientists believe may indicate a series of related events, such as the collapse of stars within a star cluster. This clustering offers clues about the environments in which these bursts occur and the stellar populations involved. Did you know that gamma-ray bursts have even been linked to the search for extraterrestrial intelligence? Some scientists propose that advanced civilizations might harness the energy of gamma-ray bursts or use similar emissions as a form of communication. While purely speculative, this idea adds an intriguing dimension to the study of these powerful cosmic phenomena. And here's something particularly interesting about the colors associated with gamma-ray bursts. While they are known for their intense gamma radiation, they also emit light across a broad spectrum, including visible and infrared. This multicolored display can reveal different physical processes occurring within the burst and its aftermath, enriching our understanding of these complex events. Have you contemplated the role of gamma-ray bursts in shaping galaxies? These bursts can influence star formation rates within galaxies, either triggering new formations or inhibiting them. Their immense energy outputs can affect the surrounding interstellar medium, demonstrating the far-reaching impact these bursts can have on galactic evolution. Here's a surprising fact. Some gamma-ray bursts originate from hypernovae, which are even more energetic than typical supernovae. Hypernovae occur when extremely massive stars collapse in an exceptionally violent explosion, creating a gamma-ray burst in the process. This extreme end of stellar evolution highlights the diversity of conditions that can lead to these extraordinary events. Have you ever thought about the role of gamma-ray bursts in cosmic timelines? Because they shine from such distant reaches of the universe, The light from gamma-ray bursts can take billions of years to reach us. This means that when we observe a gamma-ray burst, we are actually looking back in time, glimpsing events that occurred in the early universe. It's like peering through a window into the past, revealing the history of cosmic development. Reflecting on the variety of gamma-ray bursts, did you know that they are classified into two main types based on their duration? Long-duration bursts last more than 2 seconds and are typically associated with the collapse of massive stars, while short-duration bursts last less than 2 seconds and are often linked to the merger of compact objects like neutron stars. This classification helps scientists decode the different mechanisms behind these explosive phenomena. Here's a thought-provoking idea. Gamma-ray bursts can serve as natural laboratories for studying extreme physics. The conditions within these bursts, including intense radiation and high-energy particles, allow scientists to explore theories about particle acceleration and magnetic field interactions that would be impossible to replicate on Earth. Lastly, consider the potential of gamma-ray bursts to illuminate the dark universe. By studying the absorption lines in light from gamma-ray bursts, scientists can learn about the distribution of dark matter and dark energy, two of the most mysterious components of the cosmos. These observations contribute to our quest to understand the unseen forces that shape our universe. As you reflect on these captivating aspects of gamma-ray bursts, may your curiosity about the universe's wonders guide you into a peaceful slumber. Reflecting on the vast universe, let me share something intriguing about gamma-ray bursts and their relationship with black holes. When a gamma-ray burst occurs, it often signals the birth of a black hole. These bursts can mark the dramatic moment when a massive star collapses under its own gravity, creating one of these enigmatic cosmic objects. Can you imagine the incredible transformation taking place in such a short span of time? Here's a curious fact. Gamma-ray bursts can influence the chemistry of the universe. The intense energy released can trigger nuclear reactions in surrounding material, potentially leading to the formation of new elements. This process, known as nucleosynthesis, illustrates how these bursts can contribute to the cosmic abundance of elements. Speaking of elements, did you know that gamma-ray bursts might have played a role in the conditions necessary for life? By delivering heavy elements across the universe, gamma-ray bursts could have influenced the chemical composition of planets, including Earth. These elements are essential for life as we know it, suggesting that gamma-ray bursts might have a more significant role in the story of life than we previously thought. You might find it fascinating that gamma-ray bursts are not evenly distributed across the sky. Their distribution hints at the large-scale structure of the universe, with bursts more likely to occur in certain regions. This pattern reflects the distribution of galaxies and galaxy clusters, offering insights into cosmic structure and evolution. Have you ever considered the impact of gamma-ray bursts on planetary atmospheres? A nearby gamma-ray burst could strip away a planet's atmosphere, drastically altering its climate and habitability. This phenomenon highlights the potential dangers posed by these powerful events and the delicate balance required for life to thrive in the universe. Here's an intriguing connection. Gamma-ray bursts and gravitational waves are sometimes linked. When two neutron stars merge, they can produce both a short-duration gamma-ray burst and gravitational waves. These ripples in space-time provide complementary information about the event, allowing scientists to study the universe in new and exciting ways. Did you know that gamma-ray bursts can be incredibly bright, even outshining the entire galaxy they reside in? For a brief moment, a gamma-ray burst can emit more light than all the stars in its host galaxy combined. This brilliant display underscores the immense power and energy involved in these cosmic events. Reflecting on the lifespan of gamma-ray bursts, they can sometimes leave behind a lasting afterglow. This afterglow occurs as the burst's shockwave interacts with surrounding material, producing radiation across multiple wavelengths. By studying this afterglow, scientists can gather information about the burst's environment and the processes at play. A fascinating aspect of gamma-ray bursts is their potential connection to the early universe. Some of the most distant gamma-ray bursts detected thus far originate from when the universe was just a fraction of its current age. These ancient bursts provide a unique glimpse into the conditions and events of the young cosmos, enriching our understanding of its early history. Let me share with you an unusual fact. Gamma-ray bursts can sometimes be associated with superluminal motion. This phenomenon occurs when objects appear to move faster than light, an illusion resulting from the geometry of the burst's jet and the speed of light. This surprising observation challenges our perceptions and demonstrates the complex nature of these cosmic events. Considering the diverse environments in which gamma-ray bursts occur, they are often found in star-forming regions. These regions are rich in gas and dust, providing the necessary ingredients for star formation. The presence of gamma-ray bursts in these areas suggests a link between the life cycle of stars and the occurrence of these explosive events. Have you ever pondered the potential use of gamma-ray bursts as cosmic lighthouses? Due to their extreme brightness and distant origins, gamma-ray bursts can serve as beacons, illuminating remote regions of the universe. By studying these bursts, astronomers can probe the far reaches of space, learning about galaxies and cosmic structures billions of light years away. Here's something thought-provoking. Gamma-ray bursts might have influenced Earth's biological history. Some scientists speculate that past gamma-ray bursts could have caused mass extinctions by stripping away the ozone layer, allowing harmful ultraviolet radiation to reach the planet's surface. This idea suggests a complex interplay between cosmic events and Earth's evolutionary path. In a surprising twist, gamma-ray bursts can help calibrate the cosmic distance scale. By measuring their brightness and redshift, scientists can estimate the distances to these events, providing a crucial tool for understanding the expansion rate of the universe. This calibration contributes to our understanding of cosmology and the universe's ultimate fate. Lastly, consider the prospect of future discoveries. As technology advances and our observational capabilities improve, new gamma-ray bursts will continue to reveal their secrets. These events hold the potential to transform our understanding of the universe, shedding light on its most profound mysteries. As you drift into sleep, let your imagination wander among the stars, where gamma-ray bursts illuminate the cosmos with wonder and awe. Imagine for a moment the spectacular force of gamma-ray bursts being so powerful that they can briefly become the most luminous objects in the universe. In a single burst that lasts mere seconds, they can release more energy than the sun will emit over its entire 10 billion-year lifespan. This staggering amount of energy is not only awe-inspiring, but also a reminder of the incredible forces at play in the cosmos. Here's something intriguing to ponder. Gamma-ray bursts can be divided into two main categories based on their duration. Short-duration bursts last less than 2 seconds, while long-duration bursts can go on for several minutes. This distinction is significant because it hints at different underlying processes for each type. Short bursts are thought to arise from the merger of compact objects like neutron stars, while long bursts are often linked to the collapse of massive stars. Speaking of massive stars, did you know that gamma-ray bursts can leave behind fascinating remnants? After a massive star collapses and creates a long-duration gamma-ray burst, it often forms a black hole or a neutron star. These remnants are the leftover cores of the original stars, adding a new layer to the life cycle of the cosmos. And here's a captivating fact. The jets of gamma-ray bursts are incredibly narrow, akin to a focused beam of light. This narrowness means that we only detect a fraction of the total number of gamma-ray bursts that occur, as many are simply not pointed in our direction. This realization suggests that the universe is even more dynamic and active than we might perceive from our vantage point on Earth. Have you ever considered the role of magnetic fields in gamma-ray bursts? They play a crucial role in shaping the jets and the overall behavior of these explosive events. Magnetic fields can channel the energy released during a burst, creating the narrow, focused jets that we observe. This interaction between extreme energy and magnetic fields is a fascinating area of study, revealing new insights into cosmic physics. Here's a thought-provoking consideration. Gamma-ray bursts can serve as natural laboratories for testing the laws of physics under extreme conditions. They provide an opportunity to observe phenomena that cannot be replicated on Earth, such as the behavior of matter at incredibly high temperatures and densities. This exploration helps scientists refine existing theories and sometimes even challenges our understanding of the universe. You might find it curious that the afterglow of a gamma-ray burst can persist for weeks or even months after the initial explosion. This afterglow, which occurs across various wavelengths, provides a wealth of information about the environment surrounding the burst. By examining the afterglow, astronomers can learn about the composition and density of the interstellar medium and gain insights into the processes that govern these cataclysmic events. In a surprising twist, gamma-ray bursts might help in the search for alien life. By studying bursts in distant galaxies, astronomers can gather data about the conditions in those galaxies, such as the presence of heavy elements and the rate of star formation. This information could hint at the potential for life to arise in other parts of the universe, drawing intriguing connections between gamma-ray bursts and the search for extraterrestrial life. Here's something that might surprise you. Despite their destructive potential, gamma-ray bursts could also play a vital role in the genesis of complex organic molecules. The energy from these bursts can initiate chemical reactions in interstellar space, leading to the formation of complex molecules that are the building blocks of life. This paradoxical aspect of gamma-ray bursts, a force of both destruction and creation, adds to their enigmatic nature. Imagine the challenge of studying something as fleeting and distant as a gamma-ray burst. Yet, with advancements in technology, scientists have developed sophisticated telescopes and instruments capable of capturing these events in real time. This capability allows for rapid follow-up observations and has led to many groundbreaking discoveries about the origins and characteristics of these bursts. Now, consider the possibility that gamma-ray bursts have cosmic siblings, fast radio bursts. These mysterious, millisecond-long bursts of radio waves might share similar origins with gamma-ray bursts. While the exact relationship between the two is not fully understood, their study might unlock new mysteries about transient cosmic events. Did you know that gamma-ray bursts can provide clues about the earliest stars in the universe? Some bursts originate from incredibly distant galaxies, offering a glimpse into a time shortly after the universe's birth. By analyzing these ancient bursts, astronomers can infer the properties of the first stars and the early formation of galaxies, providing a window into the universe's formative years. Here's a final thought to ponder as you drift into sleep. The study of gamma-ray bursts is a testament to humanity's curiosity and determination to understand the cosmos. Each discovery brings us closer to unraveling the mysteries of the universe, reminding us that even in the vastness of space, there is a wealth of knowledge waiting to be uncovered. With each new burst, we are reminded of the wonder and beauty of the universe and our small but significant place within it. As we continue our journey through the mysteries of gamma-ray bursts, let's delve into some of the more surprising aspects of these cosmic phenomena. Did you know that the light from a gamma-ray burst can momentarily outshine its entire host galaxy? Imagine the sheer magnitude of energy required to achieve such brilliance. It's a fleeting luminescence, but during that brief moment, the burst becomes the most luminous event in the universe. Speaking of light, gamma-ray bursts can sometimes create optical illusions. The intense radiation can affect the path of light, creating a mirage-like effect in space. This phenomenon can alter our perception of the burst's location, adding another layer of complexity to their study. Here's an intriguing thought. The most powerful gamma-ray bursts might be capable of triggering mass extinctions. If a burst were to occur close enough to Earth, the radiation could strip away our planet's protective ozone layer, leading to catastrophic consequences for life. While this scenario is unlikely, it underscores the potential impact of these massive explosions. On a lighter note, gamma-ray bursts are not just isolated events, but part of a cosmic network. They are often accompanied by other astrophysical phenomena, like supernovae, creating a dance of celestial events that weave together the tapestry of the universe. This interconnectedness offers a richer understanding of the life cycle of stars and the broader dynamics of the cosmos. Have you ever wondered about the role of gamma-ray bursts in the chemical evolution of galaxies? The energy from these bursts can disperse elements across vast distances, seeding surrounding regions with the building blocks of future stars and planets. This process contributes to the ongoing cycle of creation and destruction in the universe, shaping the composition of galaxies over time. It's fascinating to consider how gamma-ray bursts can influence the formation of black holes. The collapse of a massive star often leads to the birth of a black hole, with the gamma-ray burst serving as a herald of this transformation. This connection between bursts and black holes helps unravel the mysteries of these enigmatic cosmic entities. Here's a curious fact. Gamma-ray bursts can be used as cosmic lighthouses. Their predictable behavior and immense brightness make them excellent tools for measuring vast distances across the universe. By observing gamma-ray bursts in distant galaxies, astronomers can map the expansion of the universe and refine our understanding of cosmic distances. In a twist of fate, gamma-ray bursts might also aid in exploring the dark matter puzzle. The interaction of gamma rays with potential dark matter particles could provide clues to the nature of this elusive substance that pervades the universe. This intersection of gamma-ray bursts and dark matter research highlights the interconnectedness of cosmic phenomena. Consider this. Gamma-ray bursts can reveal the presence of powerful magnetic fields around neutron stars. These fields, among the strongest in the universe, influence the dynamics of the bursts and offer insights into the behavior of matter under extreme conditions. Studying these magnetic interactions deepens our understanding of both neutron stars and gamma-ray bursts. Here's something unexpected. Gamma-ray bursts may play a role in shaping the structure of the universe. The energy from these bursts can generate shockwaves that influence the formation of cosmic structures like galaxy clusters and filaments. This influence extends far beyond the site of the burst, demonstrating the reach of these powerful events. Have you ever imagined the diversity among gamma-ray bursts themselves? While they share common characteristics, no two bursts are exactly alike. The variations in duration, intensity, and afterglow reflect the unique conditions of each progenitor star, adding to the complexity and beauty of these cosmic phenomena. In another surprising connection, gamma-ray bursts are linked to the fundamental forces of nature. The extreme conditions during a burst allow scientists to test theories about the strong nuclear force which holds atomic nuclei together. By observing gamma-ray bursts, researchers can probe the limits of this fundamental force and refine their understanding of atomic interactions. Picture this. Gamma-ray bursts can serve as cosmic beacons for detecting gravitational waves. When massive stars collapse or neutron stars merge, the resulting gamma-ray burst is often accompanied by ripples in space-time. These gravitational waves offer a complementary perspective on the events, unlocking new dimensions in our understanding of the universe. Here's a remarkable insight. Gamma-ray bursts might help us learn about the very first moments of the universe. Some bursts occur so far away that they provide a glimpse into the early universe not long after the Big Bang. By studying these ancient bursts, scientists can infer the properties of the primordial universe and gather clues about its evolution. Finally, consider the ongoing pursuit of detecting gamma-ray bursts in real time. Although challenging, advancements in technology and observation strategies have led to the development of global networks that alert astronomers to a burst's occurrence. This rapid response capability has revolutionized our ability to study these events as they unfold, propelling our understanding of gamma-ray bursts to new heights. As you ponder these surprising facets of gamma-ray bursts, remember that each fact adds a layer to the intricate story of the universe. These bursts, with their immense energy and fleeting existence, remind us of the dynamic and ever-changing nature of the cosmos. In their brilliance, we catch a glimpse of the mysteries that continue to beckon us toward deeper exploration and understanding. As we continue our journey through the wonders of gamma-ray bursts, let's delve into some truly unexpected aspects of these fascinating phenomena. Did you know that gamma-ray bursts can occur in pairs? Yes, occasionally, astronomers have observed two bursts originating from the same region in quick succession. This rare event suggests complex interactions in the progenitor system, possibly involving binary star systems or multiple collapses. Here's something else to ponder. Gamma-ray bursts can temporarily outshine entire galaxies. In the instant of their occurrence, these bursts release more energy than the Sun will emit over its entire lifetime. Imagine that, a single flash brighter than hundreds of billions of stars combined. This immense power is a testament to the cataclysmic events that give birth to gamma-ray bursts. Speaking of their astounding brightness, did you know that gamma-ray bursts can be seen from billions of light-years away? Despite their brief existence, they are so luminous that their light can traverse the vast expanse of the universe, reaching us as a beacon from the distant past. This incredible range makes them invaluable tools in the study of the universe's history. In another twist, gamma-ray bursts have helped shed light on the nature of distant galaxies. By observing how the light from a burst is absorbed by interstellar gas and dust, astronomers can infer the composition and structure of galaxies far beyond our own. This information helps build a more complete picture of the universe's evolution and diversity. You might find it intriguing that gamma-ray bursts could play a role in the creation of gold and other heavy elements. The immense energy released in a burst can trigger nuclear reactions that forge these elements, disseminating them into the universe. This celestial alchemy enriches the cosmos, contributing to the formation of planets and even life itself. Have you ever considered how gamma-ray bursts are detected? The Earth is constantly bathed in gamma rays, but the bursts are so intense that they stand out against this cosmic background. Satellites orbiting our planet are equipped with sensors that monitor gamma-ray activity, alerting astronomers to any unusual spikes that might indicate a burst. Here's a curious phenomenon. The afterglow of gamma-ray bursts can last for days or even weeks. While the initial burst is brief, the fading light provides a prolonged opportunity for astronomers to study the event in detail. This afterglow is a crucial window into the physics of the explosion and the environment surrounding it. Speaking of afterglows, did you know that they can appear across the electromagnetic spectrum? From radio waves to X-rays, the afterglow of a gamma-ray burst can manifest in various forms, each offering unique insights into the nature of the burst and its aftermath. This multi-wavelength approach enriches our understanding of these complex events. Imagine this. Gamma-ray bursts might even influence the climates of distant planets. The energy from a nearby burst could significantly alter the atmosphere of an exoplanet, affecting its habitability. This interaction underscores the interconnectedness of cosmic events and their potential impact on life beyond our solar system. Let's explore another unexpected connection. Gamma-ray bursts could aid in the search for extraterrestrial intelligence. Some scientists speculate that advanced civilizations might harness the energy of these bursts, potentially creating detectable signals. This hypothesis, although speculative, adds a layer of intrigue to the quest for life beyond Earth. Did you know that gamma-ray bursts are categorized into two main types based on their duration? Short bursts last less than 2 seconds, while long bursts extend beyond that. This distinction points to different origins and processes, with short bursts typically resulting from the merger of neutron stars and long bursts from the collapse of massive stars. Here's a fascinating tidbit. The study of gamma-ray bursts has led to the discovery of entirely new classes of astronomical objects. For instance, soft gamma repeaters and anomalous X-ray pulsars were first identified through their gamma-ray emissions. These findings illustrate the role of gamma-ray bursts as gateways to new realms of astrophysical discovery. Have you ever wondered about the impact of gamma-ray bursts on space-time itself? The intense gravitational fields associated with these events can warp space-time, bending light, and affecting the paths of particles. This interaction highlights the influence of gamma-ray bursts on the very fabric of the universe. Finally, consider the role of gamma-ray bursts in fostering international collaboration. The effort to detect and study these events spans borders and continents, bringing together scientists from diverse fields and cultures. This global cooperation enriches our understanding of gamma-ray bursts and exemplifies the unity of purpose in unraveling the mysteries of the cosmos. As we drift into contemplation of these surprising facets of gamma-ray bursts, it's clear that each discovery adds depth to our cosmic understanding. These bursts, with their fleeting brilliance and profound implications that define our universe, in their study, we glimpse the boundless potential for learning and the ever-present invitation to explore the mysteries that await us in the vastness of space. Allow me to share something unexpected with you. Gamma-ray bursts, despite their seemingly random occurrence, exhibit a certain level of predictability. Some studies suggest that there might be preferred directions in space linked to large-scale cosmic structures where gamma-ray bursts are more likely to happen. This potential pattern could offer insights into the large-scale distribution of matter in the universe. It's fascinating to think about how gamma-ray bursts could have played a role in shaping life on Earth. Some researchers propose that mass extinctions in our planet's history might be linked to nearby gamma-ray bursts. The intense radiation from such an event could strip away the ozone layer, exposing life to harmful ultraviolet light. It's a humbling reminder of the delicate balance that sustains life on our world. Have you ever wondered how gamma-ray bursts are named? The naming convention is quite straightforward. They are labeled based on the date of their detection. For instance, a burst detected on March 14, 2013 would be called GRB 130314. This simple yet effective system helps scientists keep track of these fleeting phenomena amidst the vast array of cosmic events. Here's an intriguing thought. Gamma-ray bursts might help us refine our understanding of the fundamental forces of nature. By studying the polarization of gamma-ray light, researchers can test theories about the nature of gravity and quantum mechanics. This intersection of astrophysics and fundamental physics opens new avenues for exploring the laws that govern our universe. Speaking of exploration, did you know that gamma-ray bursts contribute to our knowledge of the early universe? Because they are so distant, many of the bursts we observe today occurred when the universe was much younger. By analyzing their light, astronomers can glean information about the conditions that prevailed billions of years ago, offering a glimpse into the universe's formative stages. Let me share another curious aspect. Gamma-ray bursts might have a peculiar relationship with cosmic voids. These vast, empty regions of space, devoid of galaxies, could potentially amplify the signals of gamma-ray bursts through gravitational lensing. This phenomenon occurs when the light from a distant burst is bent and magnified by massive structures, such as galaxy clusters, lying between the burst and Earth. Speaking of massive structures, the study of gamma-ray bursts has led to the discovery of hypernovae. These are exceptionally energetic supernovae that can outshine entire galaxies. Hypernovae are thought to be the progenitors of long gamma-ray bursts, and their study provides valuable insights into the life cycles of the most massive stars. Here's a surprising tidbit. Gamma-ray bursts may also help us probe the mysterious dark energy that permeates the universe. By observing how the light from these bursts stretches as the universe expands, scientists can gather clues about the rate of this expansion and the nature of dark energy. This research is crucial for understanding the fate of the universe itself. Did you know that gamma-ray bursts could also inform us about the magnetic fields in space? The afterglow of a burst can be polarized, which indicates the presence of magnetic fields. By studying this polarization, astronomers can infer the strength and orientation of magnetic fields around the burst site, shedding light on the magnetic environments in which these events occur. Consider this. The detection of gamma-ray bursts has been revolutionized by the development of specialized spacecraft. Satellites like the Neil Gehrels Swift Observatory and the Fermi Gamma-Ray Space Telescope are equipped with instruments designed to capture these ephemeral events. Their observations have significantly advanced our understanding of gamma-ray bursts and continue to unveil the secrets of these cosmic phenomena. Here's something to ponder. The study of gamma-ray bursts might one day help us resolve one of the biggest mysteries in cosmology: the nature of dark matter. Since gamma-ray bursts are incredibly luminous, they could be used to probe the distribution of dark matter in the universe. By observing how the light from these bursts is gravitationally lensed by dark matter, researchers can map its elusive presence across the cosmos. It's quite fascinating to think about how gamma-ray bursts are not just isolated explosions, but part of a larger astrophysical network. They interact with their surroundings, influencing the evolution of galaxies and the formation of stars. This interconnectedness highlights the intricate tapestry of cosmic events that shape the universe we see today. Have you ever imagined the role of gamma-ray bursts in the search for gravitational waves? These ripples in space-time, predicted by Einstein, can be generated by the cataclysmic events that create gamma-ray bursts. Observatories like LIGO and Virgo are on the lookout for these waves, and coordinated detections of gamma-ray bursts and gravitational waves could provide a wealth of information about the dynamics of these powerful events. Lastly, let's consider the future of gamma-ray burst research. As technology advances, new instruments and missions are being planned to capture even fainter bursts and study them in greater detail. These efforts promise to deepen our understanding of gamma-ray bursts, unraveling their mysteries and possibly revealing connections to other cosmic phenomena we have yet to discover. In contemplating all these surprising facets of gamma-ray bursts, we realize the profound impact these enigmatic explosions have on our understanding of the universe. They serve as beacons of knowledge, guiding us toward answers to some of the most fundamental questions about the nature of reality. As we continue to explore these cosmic bursts, we remain on the threshold of discovery, ever inspired by the wonder and complexity of the cosmos. Let's delve into a fascinating aspect of gamma-ray bursts: their role as cosmic forensics tools. Can you imagine using these powerful bursts like a detective uses fingerprints? When a gamma-ray burst occurs, it leaves behind an afterglow that can be observed across multiple wavelengths, from radio to X-rays. This afterglow acts like a cosmic signature, allowing scientists to piece together the events leading up to the burst. By examining the diminishing light, researchers can often reconstruct the life and death of the star system responsible for the explosion. It's like reading a cosmic autobiography, one photon at a time. Speaking of cosmic signatures, here's a thought-provoking fact. Gamma-ray bursts can help trace the distribution of elements in the universe. The powerful explosions create and disperse heavy elements, such as gold and uranium, into space. These elements are forged in the extreme conditions of a gamma-ray burst and then spread throughout the cosmos, contributing to the chemical richness of future generations of stars and planets. Imagine, the very gold in your jewelry might have originated from such a cataclysmic event billions of years ago. And here's something intriguing to consider. Gamma-ray bursts can illuminate the nature of black hole formation. Short gamma-ray bursts are believed to result from the merger of neutron stars or a neutron star and a black hole. By studying these bursts, scientists gain insights into the violent processes that lead to the creation of black holes, offering clues about the conditions necessary for their formation. This line of investigation not only helps us understand gamma-ray bursts, but also deepens our comprehension of black hole physics. Another interesting fact is that gamma-ray bursts might hold the key to understanding the limits of the speed of light. Some theories suggest that light traveling over vast cosmic distances could experience slight variations in speed due to interactions with hypothetical particles in space. By analyzing the arrival times of gamma rays with different energies, researchers can test these theories, potentially leading to groundbreaking discoveries about the fundamental limits of our universe. Let's turn our gaze to the concept of cosmic isotropy, which suggests that the universe looks the same in all directions. Gamma-ray bursts can test this concept by serving as random cosmic beacons distributed throughout the universe. If they appear to be uniformly distributed regardless of the direction we look, it supports the idea that the universe is isotropic. By carefully cataloging these bursts, astronomers can assess whether the large-scale structure of the universe aligns with theoretical predictions. Have you ever wondered about the relationship between gamma-ray bursts and cosmic rays? These bursts are thought to be potential sources of the highest energy cosmic rays, which are particles that travel across the universe at nearly the speed of light. When gamma-ray bursts occur, they might accelerate particles to extraordinarily high energies, sending them streaking through the cosmos. This possibility positions gamma-ray bursts as a critical piece in understanding the enigmatic origins of cosmic rays. Here's a delightful curiosity. Gamma-ray bursts can sometimes produce gamma-ray flares, long after the initial explosion has subsided. These flares can occur days or even weeks after the burst, and may hold clues about the lingering activity in the remnants of the burst. By studying these flares, scientists can probe the energy reservoirs and magnetic fields at play in the aftermath of a gamma-ray burst, adding another layer of complexity to these already intricate events. Did you know that gamma-ray bursts might even help us understand the interplay between matter and antimatter? In the intense conditions of a gamma-ray burst, matter and antimatter are thought to interact in ways that might not be observable under normal circumstances. These interactions can offer insights into the fundamental asymmetry between matter and antimatter in the universe, potentially revealing why our universe is dominated by matter rather than being a perfect balance of both. Speaking of interactions, gamma-ray bursts also shed light on the intergalactic medium, the diffuse gas and plasma that fills the space between galaxies. As the light from a gamma-ray burst travels through this medium, it interacts with the gas, revealing its composition and density. By analyzing these interactions, astronomers can map the distribution and properties of intergalactic matter, enhancing our understanding of the structure and evolution of the universe. Here's a captivating notion. Gamma-ray bursts could serve as natural probes of the extragalactic magnetic fields. These bursts generate afterglows that are influenced by magnetic fields they encounter on their journey to Earth. By studying the polarization of this light, scientists can infer the characteristics of otherwise invisible magnetic fields, offering a rare glimpse into the magnetic environment of the universe outside our galaxy. Let's consider the potential of gamma-ray bursts in testing models of space-time. Some theories suggest that space-time may have a grainy structure at the smallest scales. By examining the arrival times of gamma rays in different energy bands, researchers can test these models, potentially offering evidence for or against such fundamental theories. This line of investigation could revolutionize our understanding of the very fabric of the cosmos. And here's something extraordinary to ponder. Gamma-ray bursts might influence the habitability of planets. The intense radiation from a nearby gamma-ray burst could strip away a planet's atmosphere, dramatically affecting conditions for life. Understanding the frequency and distribution of these bursts across different epochs of the universe could inform our search for life and the potential for habitable worlds beyond our solar system. Lastly, imagine this. Gamma-ray bursts can serve as cosmic mile markers, helping us measure vast distances across the universe. By analyzing the redshift of a burst, which tells us how much its light has stretched as the universe expands, astronomers can determine how far away it is. This ability to measure distant cosmic events helps refine our understanding of the scale and structure of the universe, as well as the rate at which it is expanding. These incredible insights remind us of the profound role gamma-ray bursts play in our quest to comprehend the intricacies of the universe. As we continue to unravel their mysteries, we find ourselves ever more connected to the vast cosmos and the wonders it holds. The more we learn, the more we are inspired to explore the endless possibilities that await us in the silent, starry skies above. Let me share something intriguing about gamma-ray bursts. They are incredibly brief, yet immensely powerful. Most gamma-ray bursts last only a few seconds to a few minutes, yet in that short span, they can release more energy than our sun will emit over its entire 10 billion year lifetime. Can you imagine such a colossal energy release happening in the blink of an eye? This astonishing fact underscores the tremendous forces at play in the universe. Speaking of energies, did you know that gamma-ray bursts are categorized into two main types based on their duration? Short gamma-ray bursts typically last less than 2 seconds, while long gamma-ray bursts extend beyond that. The distinction between the two is not just about time, it's also about their origins. Short bursts are often associated with the collision of neutron stars, whereas long bursts are linked to the collapse of massive stars into black holes. These differing origins provide a window into the life cycles of some of the universe's most enigmatic objects. Here's something unexpected. Gamma-ray bursts are not only powerful, but also incredibly rare in our galaxy. In fact, they occur so infrequently in the Milky Way that we haven't observed one happening here in recorded history. Most of the gamma-ray bursts we detect originate from distant galaxies, often billions of light-years away. This scarcity adds to their mystique, as each detected burst offers a rare glimpse into distant, cataclysmic events. And here's a captivating thought. The light from gamma-ray bursts can travel across the cosmos for billions of years before reaching us. This means that when we observe a gamma-ray burst, we're seeing the universe as it was in the distant past. In essence, every gamma-ray burst serves as a time capsule, offering insights into the conditions and events of the early universe. It's a humbling reminder of our place in the vast tapestry of space and time. Let's consider the skies themselves. Gamma-ray bursts are typically detected using special space-based observatories with instruments capable of capturing high-energy gamma rays that would otherwise be absorbed by the Earth's atmosphere. These observatories, like the Swift and Fermi telescopes, are constantly scanning the skies, ready to alert scientists to the fleeting appearance of these bursts. The swift response to these alerts is crucial, as the information gathered in those first moments is key to understanding the nature and aftermath of the burst. Did you know that the afterglow of a gamma-ray burst is just as fascinating as the burst itself? After the initial explosion, the fading light can persist for days, weeks, or even months. By observing these afterglows in various wavelengths, from radio waves to X-rays, astronomers can piece together a more comprehensive picture of the burst's environment and the processes driving these extraordinary events. The afterglow provides a lingering echo of the burst, inviting further investigation and discovery. Here's something to ponder. Gamma-ray bursts may have played a role in shaping some of the universe's most fundamental structures. It's possible that the intense outflows of energy from these bursts could trigger star formation in nearby gas clouds. If so, gamma-ray bursts could influence the evolution of galaxies by seeding new generations of stars, weaving themselves into the very fabric of cosmic formation and evolution. Speaking of cosmic influence, gamma-ray bursts might also contribute to the synthesis of heavy elements. During the cataclysmic events that generate these bursts, conditions are ripe for the creation of elements such as gold and platinum. These elements are scattered across the universe, later becoming part of new stars, planets, and even life itself. In a way, gamma-ray bursts are alchemists of the cosmos, forging the building blocks of matter. Imagine this: Detecting gamma-ray bursts can be like solving a cosmic puzzle. Scientists use a combination of observational techniques, theoretical models, and computational simulations to unravel the mysteries of these bursts. Each piece of data, whether it's the burst's duration, luminosity, or spectral characteristics, helps fit together a larger picture of their origins and impact. The collaborative nature of this research is truly a testament to human ingenuity and curiosity. Here's a delightful curiosity. Some gamma-ray bursts might be linked to supernovae, the explosive deaths of massive stars. In certain cases, the gamma-ray burst is followed by a visible supernova explosion, creating a spectacular cosmic show. By studying these events, astronomers can explore the intricate connections between different types of stellar deaths and the diversity of phenomena they produce. And here's something fascinating to wrap your mind around. Gamma-ray bursts provide a natural laboratory for studying extreme physics. The conditions during a burst are so extreme, temperatures reaching millions of degrees, magnetic fields billions of times stronger than Earth's, that they allow scientists to test our understanding of physical laws under such circumstances. The insights gained from studying gamma-ray bursts could potentially unlock new realms of physics, challenging and expanding our current theories. As we delve deeper into the mysteries of gamma-ray bursts, we find ourselves continually awed by the universe's capacity for wonder and complexity. Each discovery not only enhances our knowledge, but also fuels our imagination, propelling us forward in our quest to unravel the secrets of the cosmos. The universe, with its endless array of phenomena, beckons us to explore and dream, reminding us of the interconnectedness of all things, from the smallest particles to the grandest celestial events. Let me share something intriguing with you. Gamma-ray bursts, despite their explosive nature, are surprisingly helpful for mapping the universe. When a gamma-ray burst occurs, its light can be used to measure the vast distances across the cosmos. By analyzing the light's redshift, astronomers can determine how far away the burst occurred, adding a piece to the puzzle of cosmic cartography. This process helps us understand the structure of our universe on an immense scale, as each burst paints a small stroke in the grand picture of space. Did you know that gamma-ray bursts might have had a profound impact on life here on Earth? Some scientists speculate that a nearby gamma-ray burst could have triggered mass extinctions in our planet's past. The intense radiation from such an event could strip away the Earth's ozone layer, exposing the surface to harmful solar radiation. It's a reminder of how interconnected we are with the cosmic events happening millions of light years away. Here's a mind-bending thought. Gamma-ray bursts are not just a phenomenon of the present. They have been happening for billions of years, stretching back to when the universe was still in its infancy. Observing these ancient bursts provides a window into the early universe, offering clues about the conditions that prevailed shortly after the Big Bang. It's as if we're peering into the universe's baby photos, trying to piece together its youthful adventures and escapades. Speaking of the universe's youth, some gamma-ray bursts occur in the most distant galaxies, known as high redshift galaxies. These galaxies are so far away that their light has taken billions of years to reach us. When we detect a gamma-ray burst from such a distant galaxy, we're essentially looking back in time, witnessing events from an epoch when galaxies were still forming and evolving. It's like watching an ancient documentary unfold before our very eyes. Here's something truly fascinating. Gamma-ray bursts can outshine entire galaxies for brief periods. For a few seconds or minutes, a single burst can emit more energy than all the stars in a galaxy combined. This staggering brightness is what makes them detectable across the universe, even from billions of light-years away. Imagine the cosmic fireworks show that such an event would create, a fleeting but magnificent flash illuminating the vast darkness of space. And here's a captivating twist. Not all gamma-ray bursts are created equal. Some bursts, known as ultra-long gamma-ray bursts, can last for several hours, much longer than the typical short or long bursts. These ultra-long bursts are thought to arise from the deaths of supergiant stars, which have a much larger mass and size than typical stars. This peculiar class of gamma-ray bursts challenges our understanding and pushes the boundaries of what we know about stellar evolution and death. Let's explore another intriguing aspect: the role of magnetic fields in gamma-ray bursts. During a burst, the magnetic fields surrounding the explosion can become incredibly twisted and intense. These fields are crucial for accelerating particles to nearly the speed of light, creating the high-energy jets that we observe as gamma-ray bursts. Understanding these magnetic interactions is key to unraveling the physics behind these cosmic events, shedding light on the forces that govern the universe. Here's a delightful surprise. Gamma-ray bursts can be accompanied by gravitational waves. When binary neutron stars collide, they can produce both a short gamma-ray burst and ripples in the fabric of space-time known as gravitational waves. Detecting both signals from the same event provides an unprecedented opportunity to study the universe through two different lenses, offering insights into the nature of gravity, matter, and energy. Speaking of dual signals, gamma-ray bursts can also produce high-energy neutrinos, elusive particles that rarely interact with matter. Detecting these neutrinos alongside the gamma rays provides another valuable tool for probing the intense environments where bursts occur. Neutrinos can travel through space unimpeded by matter, carrying information from the heart of the explosion all the way to our detectors. Let me share a little-known fact. The study of gamma-ray bursts has inspired new technologies. Instruments developed for detecting these bursts have been adapted for other scientific applications, including medical imaging and cancer treatment. This cross-pollination of technology highlights the far-reaching impact of astronomical research, where the quest to understand the cosmos can lead to innovations that benefit humanity in unexpected ways. Here's a thought to ponder. Gamma-ray bursts have helped refine our models of the universe's expansion. By studying bursts from different epochs, astronomers can gather data on how the universe has expanded over time. This information complements other cosmological observations, contributing to a more complete picture of the universe's history and fate. And consider this: gamma-ray bursts have been proposed as potential beacons for extraterrestrial civilizations. Some researchers speculate that advanced civilizations might harness the energy of gamma-ray bursts, using them as signals or even as a form of communication across the vast stretches of space. While purely speculative, this idea underscores the allure and mystery that gamma-ray bursts hold for scientists and dreamers alike. Finally, let's reflect on the collaborative nature of gamma-ray burst research. With telescopes and detectors spread across the globe and in space, scientists from various countries and disciplines work together to unravel the mysteries of these cosmic phenomena. This global collaboration exemplifies the unity and curiosity that drives scientific exploration, a shared journey to understand our universe and our place within it. As we conclude this gentle exploration, may you carry with you a sense of wonder and appreciation for the dazzling complexities of the cosmos, where each gamma-ray burst tells a story written in the stars. Let me share something truly captivating. Gamma ray bursts are among the most energetic and explosive events in the universe, yet they often begin as phenomena hidden within the depths of thick clouds of gas and dust. It's only when the intense energy of the burst pierces these obscuring cocoons that we catch a glimpse of their brilliance, revealing secrets from within their shrouded origins. And here's an astonishing thought. The energy released by a single gamma ray burst can be equivalent to the energy our sun will emit over its entire 10 billion year lifespan. Imagine all that power compressed into just a few fleeting moments. Speaking of extremes, gamma ray bursts can occur at any time, and their unpredictable nature keeps astronomers on constant alert. It's as if the universe is playing a cosmic game of hide and seek, offering glimpses of its fireworks on its own terms. In this sense, gamma ray burst research is a delicate dance of patience and vigilance, always ready to catch the next unexpected flash. Here's an intriguing twist. The afterglows of gamma ray bursts, the glowing embers left in their wake, can last for days or even weeks. These afterglows emit light across various wavelengths, providing a rich tapestry of information that helps scientists decipher the mysteries of the burst's origin and surrounding environment. Did you know that gamma ray bursts can have siblings? Sometimes, a single gamma ray burst can produce multiple jets of energy, resulting in separate bursts that are related but distinct. This phenomenon, known as a jet multiplicity, challenges scientists to understand the complex processes within the exploding star. It paints a picture of a stellar explosion with intriguing layers and dimensions, much like a cosmic kaleidoscope. And here's another remarkable fact. Some gamma ray bursts are thought to be associated with the formation of black holes. When a massive star collapses, the resulting burst of energy might signify the birth of a black hole, offering us a rare glimpse into one of the universe's most enigmatic creations. Imagine this. Gamma ray bursts can vary widely in their spectra, meaning the wavelengths of light they emit. This diversity in spectral signatures allows scientists to classify them and gain insights into their underlying mechanisms. It's as if each burst carries its unique fingerprint, waiting to be decoded. Moreover, the study of gamma ray bursts has paved the way for discoveries in other areas of astrophysics. For instance, understanding the processes that lead to gamma ray bursts has shed light on the life cycles of stars, the dynamics of supernovae, and the formation of neutron stars. Gamma ray bursts, in essence, serve as a bridge connecting various celestial phenomena, enriching our understanding of the cosmos. Here's something truly intriguing. Some gamma ray bursts might occur in galaxies so faint and distant that they are otherwise undetectable. These dark bursts provide rare opportunities to study the most remote corners of the universe. By observing these elusive bursts, astronomers can learn about the conditions in the early universe and the processes that shaped its evolution. Speaking of evolution, gamma ray bursts have played a crucial role in the development of our understanding of cosmic elements. As the violent deaths of massive stars, they distribute heavy elements like gold and platinum into the cosmos, contributing to the chemical richness of galaxies and even our own planet. Can you imagine the sheer scale of a gamma ray burst's reach? These bursts can impact their surrounding galaxies, influencing star formation and even altering the interstellar medium. They act as cosmic sculptors, reshaping their environments in profound and lasting ways. As we consider the vastness of their influence, it's fascinating to think about the role they might play in the larger cosmic ecosystem. And here's an enchanting notion. While gamma ray bursts are incredibly intense, they are also fleeting. Each burst is a reminder of the transient nature of cosmic events, highlighting the delicate balance of time and space that defines our universe. Reflecting on the collaborative efforts to study gamma-ray bursts, it's heartening to see how these cosmic mysteries bring together scientists from all over the world. This collaboration transcends boundaries and unites people in a shared quest for knowledge, reminding us of the power of human curiosity and the magic of discovery. In the grand tapestry of the universe, gamma-ray bursts serve as brilliant threads, weaving together stories of stellar life and death, cosmic creation, and the boundless wonder of the night sky. As we journey through these celestial tales, may you find comfort in the knowledge that we are all part of something vast and magnificent. Each gamma-ray burst, with its fleeting brilliance, invites us to pause and reflect on the beauty and mystery of the cosmos. And so, as the stars twinkle above, let this gentle narrative guide you into a realm of dreams where the universe's stories continue to unfold in whispers carried by starlight. Let me share something astonishing with you. Gamma-ray bursts are, in fact, the most luminous electromagnetic events known to occur in the universe. Imagine that for a moment. Their brightness is so intense that they can outshine an entire galaxy for a brief period. Isn't it fascinating how such ephemeral events can leave such an indelible mark on the cosmos? Now, this is quite surprising. There are actually two main types of gamma-ray bursts, known as long and short bursts. Long bursts last more than 2 seconds and are typically associated with the collapse of massive stars, while short bursts last less than 2 seconds and are thought to result from the collision of compact objects, like neutron stars or black holes. Here's something to pique your curiosity. Gamma-ray bursts are detected not just by ground-based telescopes, but also by instruments on spacecraft. These spacecraft can capture the bursts from above the Earth's atmosphere, where gamma rays are not absorbed. Speaking of capturing these bursts, did you know that the first gamma-ray burst was discovered quite by accident? It was detected in the late 1960s by the Vela satellites, which were originally launched to monitor nuclear explosions on Earth. Who would have thought that a tool for peace would end up revealing one of the universe's greatest secrets? Now imagine this. The energy from a gamma-ray burst is released in a matter of seconds, but it travels across vast distances of space, sometimes taking billions of years to reach us. By the time we observe them, we are essentially peering back in time, witnessing events that occurred long before the Earth itself was formed. Here's a curious twist. Some gamma-ray bursts have been identified as originating from regions near the center of galaxies, which are often areas teeming with stars and other celestial phenomena. This suggests that they might be linked to the dynamic environments found in these bustling cosmic neighborhoods. And isn't this surprising? The gamma rays themselves cannot penetrate the Earth's atmosphere, which means they must be studied using specialized satellites equipped with sensors to detect these high-energy photons. It's a marvelous example of human ingenuity, our ability to design technology that reaches beyond our planet to unravel the mysteries of the universe. Speaking of technology, the Swift satellite has been a game-changer in the study of gamma-ray bursts. Launched in 2004, it can quickly pinpoint the location of a burst, allowing scientists to direct other telescopes for follow-up observations in mere seconds. Here's something you might find interesting. While gamma-ray bursts were once thought to be rare occurrences, we now know that they happen almost daily across the universe. Thanks to modern detection methods, astronomers are able to observe these events far more frequently than before, offering a wealth of data to analyze. This reminds me of another intriguing aspect. Because gamma-ray bursts can be observed from such great distances, they serve as beacons, illuminating the structure of the universe and helping scientists study the rate of cosmic expansion. Now, let me tell you about something particularly striking. The afterglows of gamma-ray bursts are sometimes detected in radio wavelengths, long after the initial burst has faded. These radio afterglows provide additional clues about the environment surrounding the burst, including the density and composition of the interstellar medium. Isn't it amazing how one event can leave such a prolonged impact, echoing across various forms of light? Speaking of lingering impacts, gamma-ray bursts have also been a subject of interest in the search for extraterrestrial life. Some scientists speculate that intense radiation from a nearby gamma-ray burst could potentially sterilize a planet. It's a sobering thought, yet it underscores the importance of understanding these phenomena and their potential effects on the cosmos. And here's an intriguing possibility. Gamma-ray bursts could be used as a cosmic yardstick for measuring distances in the universe. By studying their brightness and the redshift of their light, astronomers can estimate how far away they are. This method supplements existing techniques and helps refine our understanding of the universe's scale. Now, imagine the interplay of forces required to produce such a burst. The energy involved is not just immense, it's also extraordinarily focused, released in narrow jets that must be oriented toward Earth for us to detect them. The probability of such alignment makes the gamma-ray bursts we observe all the more remarkable. And here's a captivating notion. Gamma-ray bursts are thought to contribute to cosmic rays, high-energy particles that travel through space. These cosmic rays could shed light on processes occurring in extreme environments and have implications for our understanding of particle physics. Finally, consider the collaborative spirit that drives gamma-ray burst research. Scientists across the globe, from various fields, come together to study these fleeting events, sharing data and insights. This collective effort highlights the power of human curiosity as we strive to piece together the intricate puzzle of the universe. As you drift into a peaceful slumber, let these stories of gamma-ray bursts carry you to the farthest reaches of the cosmos, where wonders await in the endless dance of stars and light. Let me share something fascinating with you. The sheer brightness of gamma-ray bursts is almost beyond comprehension. For a brief moment, they can outshine entire galaxies, emitting more energy than the sun will produce over its entire lifetime. Can you imagine such a dazzling spectacle taking place in the cosmos, invisible to the naked eye from Earth? It's humbling to consider the vast scales of energy involved. Now, here's something that might surprise you: the ability of gamma-ray bursts to illuminate the earliest epochs of the universe. These bursts can be so distant that the light we detect today was emitted when the universe was just a fraction of its current age. By studying these ancient signals, scientists can glean insights into the conditions of the early universe, long before galaxies like our own Milky Way had formed. Did you know that the energy of a gamma-ray burst is concentrated into a beam? These beams are incredibly narrow, which means only a small fraction of them are actually aimed toward Earth, allowing us to observe them. The precision required for this alignment is truly astonishing, much like threading a cosmic needle, as it were. Here's a curious fact. Some gamma-ray bursts are associated with supernovae, the explosive deaths of massive stars. This connection provides astronomers with a unique opportunity to study the life cycles of stars and the transformation of matter. It's a reminder of the cyclical nature of the universe, where endings give rise to new beginnings. Speaking of transformations, gamma-ray bursts can also influence the surrounding interstellar medium. When these bursts occur, They can ionize nearby gas, potentially triggering new waves of star formation. Imagine the ripple effects of such a phenomenon, where a single burst sets off a cascade of new stars being born across the cosmos. Here's something to consider: the role of gamma-ray bursts in testing the limits of physics. These events push our understanding of gravity, electromagnetism, and nuclear forces to their extremes. By observing them, physicists can test theories in conditions that cannot be replicated on Earth, offering glimpses into the fundamental workings of the universe. Another intriguing aspect is the duration of the afterglow that follows a gamma-ray burst. While the initial burst lasts mere seconds, the afterglow can linger for weeks or even months. This extended illumination allows astronomers to continue studying the event long after its explosive start, offering a prolonged view into the cosmic environment in which it occurred. Speaking of prolonged observations, gamma-ray bursts have also been pivotal in studying dark matter, that elusive and invisible component of the universe. By analyzing the distribution and impact of these bursts, scientists hope to uncover more about the mysterious substance that makes up a significant portion of the cosmos. Let me tell you about a standout discovery: the incredibly high redshift of some gamma-ray bursts. Redshift measures how much the wavelength of light has stretched as it travels through the expanding universe. Some of these bursts have the highest redshifts ever recorded, signaling that they originated from the very distant past, when the universe was in its infancy. Such measurements help refine models of cosmic expansion and evolution. Here's an enchanting notion: the potential of gamma-ray bursts to serve as natural probes of the intergalactic medium, the vast stretches of space between galaxies. As the light from a burst travels through this medium, it can pick up signatures of elements and compounds, offering clues about its composition and the conditions it endures. Now, consider the diversity of gamma-ray bursts. While they are broadly categorized into long and short bursts, each event is unique with its own characteristics and surprises. This diversity challenges scientists to continually refine their understanding and develop new models to explain these enigmatic phenomena. Speaking of challenges, gamma-ray bursts also present intriguing puzzles related to magnetic fields. Some bursts are thought to be powered by rapidly rotating neutron stars with strong magnetic fields known as magnetars. These extreme conditions test the boundaries of our knowledge about magnetism in the universe. Here's a provocative thought: the potential for gamma-ray bursts to inform our understanding of the fate of the universe. By studying their distribution and frequency, scientists gain insights into the large-scale structure of the cosmos and its ultimate destiny, whether it will continue expanding indefinitely or eventually collapse. Finally, consider the beauty of collaboration in unraveling gamma-ray bursts. From satellite missions to ground-based telescopes, a global network of scientists works together to capture and interpret these fleeting bursts of light. This collective effort demonstrates the power of shared curiosity and the human drive to explore the unknown. As you gently drift off to sleep, let these captivating stories of cosmic explosions and their far-reaching consequences weave into your dreams, transporting you to the farthest corners of the universe where the dance of stars and light never ceases.